Hey everybody, this is Nick from First Coast Math Clinic. In this video, I'm going to show you how to graph inequalities. Let's get into it. So our first inequality is y is greater than 1/3 x minus 2. And to graph this, we can use what we know about slope-intercept form, which is y equals mx plus b, because our slope and our y-intercept are in the same location, even though instead of an equal sign, we have an inequality here. So our slope is 1/3, and our y-intercept is -2. So we know that that y-intercept is at the location 0, -2. So this gives us enough information to graph this line. So I'm going to graph it in red. So I'm going to start at 0, -2 on the y-axis. Then using our slope, I'm going to go up 1 over 1, 2, 3, up 1 over 1, 2, 3. And because we have just a greater than, not greater than or equal to, we're going to connect these using a dashed line, not a solid line. And then I want the points to the left as well. So I'm going to go down 1, back 3. So I'm going to go down 1, back 1, 2, 3, down 1, back 1, 2, 3. And again, use a dashed line to connect these points. So this is our graph for our inequality. Y is greater than 1/3 x minus 2. And now we have to figure, okay, where are we going to shade? Where's our solution set? So let's test a point. And an easy point to test is going to be 0, 0. So if I test that point 0, 0 back in our inequality, we're going to have 0 is greater than 1/3 times 0 minus 2. And I get 0 is greater than -2, which is true. So our solution is going to be above our line. So for our solution set, we want to shade all the values above this line. So I'm going to shade that in red. So our solution set is going to be right here. So it's going to be all the values above our inequality. Y is greater than 1/3 x minus 2. And since it's greater than, not greater than or equal to, we're not including the points that are actually on this dashed line here. All right, let's move on to example number 2. So for number 2, we've got y is less than or equal to 2x plus 4. So again, we can identify our slope as 2 over 1 and our y-intercept as 4. So that's 0, 4. So let me plot this in green. So 0, 4 is right here. Then following our slope, I'm going to go up 2 over 1. And I want points on the left, so I'm going to go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And our sign here is less than or equal to. Since it's less than or equal to, we want to connect these points using a solid line. So I'm going to use a solid line to connect these points. So this is the line for y is less than or equal to 2x plus 4. Now we have to figure out, well, what direction are we going to shade? Should we shade to the right or should we shade to the left? Where is our solution set? And again, an easy point to test is going to be that 0, 0. So let's test 0, 0 in our inequality. So we're going to have 0 is less than or equal to 2 times 0 plus 4. And we get 0 is less than or equal to 4, which is a true statement. So our solution set is going to be to the right. So I'm going to shade all the values to the right where that point 0, 0 is. Let me shade that in green. And in this solution, we're including the points that are on this line. Since our original inequality was y is less than or equal to 2x plus 4. So we're going to include the points that are on that line compared to number 1, where we did not include the points on that line. All right, let's look at example number 3. So for number 3, we've got 2x minus 3y is greater than 6. So in this inequality, we basically have it written in standard form. I want to rewrite this in slope-intercept. I want to get that y by itself. So to do that, let's start by subtracting the 2x and 2x from both sides. So we've got negative 3y is greater than negative 2x plus 6. Now let's divide by negative 3. Divide by negative 3, and divide by negative 3. The negative 3's cancel out on the left, and we get y. And then negative 2 divided by negative 3, the negatives cancel out. So we're going to get 2 over 3 x. 6 divided by 3 is going to give us, it shouldn't be positive, it should be negative. So we're going to get negative 2. Now what happens to this inequality? If you remember, whenever we multiply or divide an inequality by a negative, we have to flip the inequality. So instead of greater than, it's going to become less than. All right, so we've got y is less than 2/3 x minus 2. So now we can identify our slope, which is 2/3. We can identify our y-intercept, which is negative 2. So that point is 0, negative 2. So let me graph this in. You do blue. So I'm going to start at 0, negative 2. Then using our slope, I'm going to go up 2 over 3, up 2 over 3. And then we can reverse that. To get the points on the left side, I'm going to go down 2 and back 3, down 2, back 3. And since this sign is less than, not less than or equal to, we want a dashed line. We don't want a solid line. So now let's check a point and see what direction we're going to shade. Our point is going to be 0, 0. So let's test that point, see if we're going to shade above or below this line. Test our point 0, 0. So we're going to get 0 is less than 2/3 times 0 minus 2. So we're going to get 0 is less than negative 2, which is false. All right, 0 is not less than negative 2. 0 is greater than negative 2. So our solution is not going to be here. It's not going to be where that 0 is. It's going to be below that line. So let's shade below the line. So I'm going to shade that in. And again, since our line here is dashed, our solution does not include the points on this line. Since our inequality is y is less than, not less than or equal to, our solution is just our shaded section, not the actual points on the line. All right, so this video was on how to graph inequalities on the coordinate plane. I hope this video helped you understand that concept a little bit better. If you like this video, leave a like, comment, and subscribe. This is Nick from First Coast Math Clinic.